Hello and welcome to part 8 of QED's Data 2. So we've seen we have some variables we expect to find some correlations between, but the correlations are very weak. One possible reason is that these variables are very skewed and that Pearson correlation coefficient often fails to find correlations when we have non-normal distributions. Two ways to address that I'll show you briefly. One is to use logarithms to reduce the skewness of the variables, and the other one is to use a different form of correlation coefficient. So first of all, we'll try the logarithms, which is explained here. So here's the command to do that, generate this one. I'll do both of these in one step. So I'm going to generate this logged variable, and notice it's going to be the monthly income. And we add 1 because if monthly income is 0, then log is not defined, so we have to add 1. That's often done when we're taking logs. And also, the name of it is very standard if you have a variable and you take the log of that variable to name the new variable just with L in front of the old variable. So if you see L's in front of variables, it means they probably had been turned into log form. So into the working file, do file, we'll just put these commands. So that's going to generate the two logged variables, it's going to label them, and then I think we want to draw the histograms for them as well, so we'll do that. 2. And then we'll check the correlations again. So let's generate it. Look at the first histogram. So that's the histogram for logged household remittances. And then finally the other histogram is this one. Logged monthly household income. Okay. And as I note back here, it's easier to see we're having them all together. So here's the original versions of remittances and income, very, very skewed. Here's the logged version, so you can see in both cases it's become much more normal because the large values have been compressed down. I've actually gone a step further here because these 0 incomes, I think that's an error in the data file because it's impossible for a household to have 0 income. Even if essentially they're being given things to ease or given a pension, that still counts as income, otherwise they couldn't survive as a household. If we remove those, then you get this much more normal situation, much more normal graph. And I did this in here by using the if command, so draw the histogram for logged monthly income if monthly income is greater than 0. So I just got rid of all the ones where it's not, where it's equal to 0. So finally, on this part, we want to examine the correlations. So we'll take the correlations between the logged variables. Yeah, so that's just the same command as before, except using the logged version for monthly income, logged version for remittances. So what that looks like. Let's keep that. Where is data gone to? Hidden under all these windows. There it is. Okay, good. And we can see that the correlations are now bigger than they were. Still not huge, but they're larger than they were between household adults and logged monthly income. Not so much with the remittances, still quite low there. And the relationship between the remittances and income is, again, slightly larger correlation coefficient, but still not very big, but larger. So that's one solution then, is to take logs to try and remove the skewness, which successfully remove the skewness, but still not huge correlations. At least they don't look very strong. The final thing we'll do today is look at a different correlation coefficient called Spearman's. It's an alternative to the standard one. It's more effective when data is not normally distributed, and it's also should be used with ordinal data, such as the scores in this data set where people are saying how happy or how satisfied are we with life on a 1 to 10 scale. How satisfied were you with life 5 years ago? How satisfied was your father or mother in life with life? Those kind of ordinal opinion type scales, you should really use Spearman's correlation. The basis of this, it works on ranks. So it replaces the actual values in this data with the ranks. So this would get 1s, it's the highest value, and so on, 2, 3, 4, and they count them like that. That's the correlation between the ranks. So to do this, I'll just put all the commands in at once, just to work out the Spearman's coefficients. As well as looking at these three variables, adults, monthly income, remittances, we'll also look back at the dependence ratio thing, how that's related to per capita income, and then we'll also repeat this, as well as using the Spearman's, we use the logged variables as well. So we do the whole thing. So here come the commands to put into the log file, not the log file, the do file. Space. So this is Spearman's correlation coefficients for those combinations of variables. Let's see what we get with that. What does stata make of that? There. So here's what you find. See, all still not huge, but larger, all positive, even between the household adults and remittances, and between remittances and monthly income now. And a couple of more things to notice. Still a negative here, as you'd expect, because dependent ratio goes up, you expect monthly per capita monthly incomes to go down because there are more people to feed, essentially, with fewer workers. And again, it's larger and negative, as you expect. Another strange thing is that, it might be strange at first, is that the coefficients are precisely the same for the logged versions as they are for the non-logged versions. And that's because, as I said, Spearman's is working on the order of the numbers. So taking logs hasn't changed the order of the numbers, so it doesn't change the results to get the similar things there. Okay, before we give up on these correlation coefficients, I should point out that there will be many, many things influencing monthly income, as well as just how many adults there are. There'll be the education level of the adults, whether they have good land or bad land, they live near a town, the economy is booming near them, there's good infrastructure, they have wealthy relatives, many, many other things. So you wouldn't expect there to be a large correlation coefficient necessarily, even if there is definitely a link between the number of adults and monthly income. Not necessarily going to be a big correlation coefficient, so that could be as big as we'd expect. And in future weeks, you'll see ways of A, eliminating the effects of other things, and B, also seeing whether that really is, you know, a substantial number or not in this kind of situation, or whether it could just be random. So where are we with the process? Oh yes, now we want to finish off the file at last by putting this in, which stops it recording results. And then we come to the $64,000 question. Putting it into the log file. Okay, so that's now finished. Now we go back to stata, find stata, clear everything. And now I'm going to reload the data, to reload the file from here. Okay, so now it's gone back to, all the work we did has gone. All the renaming of variables, creating new variables, everything has gone completely. But hopefully now, if we go back to here, we should be able to, just by pressing this, do it all again. Now, is stata in the background printing out red ink saying rubbish, or is it being happy? What you can't see is that over here, unfortunately not on the bit of screen, you can't see all the various graphs and they're popping up. And here we can see all the results being printed out. Hopefully down to the last thing we did. It's still, where's the Spearman's? Here they are, there's the Spearman's coming out. And there's the final chart. So it's done everything. So you can just execute all your commands again at any stage in the future. You can go back and adjust things. You can do it with a slightly adjusted data set and run it all again. You can hand it in to people if you're doing a study to say exactly what you've done. So very recommended you save your work. Build up your work like I did in this session here. Typing commands in, executing them, getting rid of the errors, executing them, keeping a log file, and then saving it at the end. So then you can execute it all at once. If you want to see the results you've had again, they're not lost, they're stored in this log file. So where might that be? And there it is, it's in this folder. I don't remember where you put it. And you can open this up, you don't even need stata to open it, you just click it and it opens in Notepad or Word or whatever you have. And there's all the print out results, so you can just get that to use in your essay, your report, type it into a table, format it beautifully and hand it in. So you're good to go. Excellent. So I hope in your future work you'll make heavy use of these do files to organise your analysis, and we'll be using them in the rest of the semester. But for now, thanks for watching.